Hello, everyone. My name is Kenneth Obayuwana, and I'm a journalist. I work with AgriTech Digest, and today we'll be having a conversation around the future of sustainable farming. Joining me on this stage is Dan from Biotalys, and then Laetitia from Astanor, and then Guy, who is also into open source. So today we're going to be looking at conversations around the future of sustainable farming. At the moment, farming is in the inflation point, balancing productivity, nutrition, sustainability, and environmental impact. But the reality is that the truth about the whole issue is that it's not really about technology, or it's not really about the technology that will drive the future of sustainability in agriculture. But what really matters is who controls it. Who controls it? Who does it benefit? And how do we ensure farmers, who is at the intersection of these all conversations, benefit from this, or from the future of sustainable farming? These are all the things we'll be discussing around precision agriculture as well. We'll be looking at some issues around precision agriculture. We'll be looking at the advancement around biotech in the agricultural space as well, along with open source. So without wasting much time at all. Okay. So without wasting much time at all, well, before we go on, before we jump into the first questions for our panelists today, I would love us to give them 1 minute each for them to tell us something amazing about themselves, what role and what criteria, or what excites them most about the future of sustainable farming. Over to you.
So hello, my name is Eva. I work for Biotalys as the head of regulatory affairs and sustainability. And I'm most excited about the future of sustainable farming. In the future, I'm looking forward to what proteins will bring as crop protection products.
Okay, thank you.
Hi, everyone. First of all, I would like to apologize because I know that we are the last thing that is sitting between you and the Friday beer. So sorry for this. That being said, I'm Laetitia, working as a principal for Astanor, which is an impact VC fund focused on food and ag. We invest in Series A and Series B startups, tickets that range from 3 to 15 million euros, both in Europe and in the US. As for the most exciting thing for me in sustainable farming, well, obviously biologicals.
Yes.
Which I think is definitely part of the future of sustainable farming, and that has had too much of a snake oil history in the past decades.
Thank you. What's your guy?
Good day, everyone. My name's Guy. I'm a researcher at the University of Copenhagen, and I guess working in weed science. So I really love weeds. That's maybe one interesting thing. But I'm most excited, I think, about how technology and advancements in large language models is really helping turn ideas into reality. I think that's really exciting for agriculture, where we can have farmers who are, I guess, understand the industry and their problems so well, all of a sudden start to develop solutions for their ideas. So I think that's really exciting for the future of ag.
Great, thank you very much. So without wasting time, we're jumping into the first questions. But don't forget, please, you can scan the QR code, or you can send your questions to us via the QR code or via the app, and then we'll take the questions from here. All right. My first question will be, my first question here is, farmers are under pressure. So my first question is for Evan, and we're going to be looking at crop protections and the future of the input. All right. So farmers are under pressure to reduce chemical inputs while maintaining yield. What does the next generation of crop protection looks like?
Yes, so the next generation of crop protection products is very diverse. There is not such a thing as one characteristic that can describe them all. But what unites them is that they are more environmental friendly and that they cannot contaminate soils and water. But actually, we can see that there are. We always say that biocontrol products can be divided in 4 categories. So you have the macroorganisms like bees and predatory mites that predate diseases. That's the first category. Then you have microorganisms like bacillus and trichoderma, who are already very widespread. Then the third category is the semiochemicals that are products that disrupt, for instance, mating between insects. And then the fourth category, which is the most interesting one, of course, because Biotalys is working on it, is the natural substances. Proteins are an example of that, and they can be a big changer in the future. Because biological products always had the impression that they were a little bit like snake oil, that they did not have the efficacy of chemicals, but that is changing now. We see that the efficacy of biologicals is also increasing. Farmers in the past always told, yeah, biologicals, the price is higher and the efficacy is lower, but that is something that at Biotalys we want to change. And yeah, we are working on that with our technology.
Okay, thank you very much. Well, let me ask, your organization focuses on biological solutions. Are they true viable at scaling, or are they still niche? What regulatory hurdles stands in the way?
So yes, surely, biological solutions are surely scalable. It's on this moment, it is still a niche, so biological products is 5 to 10% of the market today. But the reason why it's going slowly is because of the regulatory burdens. So I don't know if people know how long it takes in Europe after you have a product developed, a crop protection product developed before it can be registered. But in Europe, on average, that's 10 years. So that's a very long time. And you need investors that have patience before you go there. But the reward is huge. Thank you. So the regulatory hurdles are huge. Also in Europe we realize that, but it's not so easy to deregulate. It's not only in Europe, it's also in other parts of the world that this is not straightforward. There is a lot of authorities trying to work on it, but like also in the US it's now going slower. And the main thing that is a problem for businesses is that the unpredictability of these timelines. Because if you ask different consultancy firms, how long does it take before you can go to the market, then everybody will say something else for another region. And that's because it's not exactly clear. So to work on more predictable timelines would be something good to help businesses to make sure they can bring their products to the market.
Nice. Okay, let's talk about investment and scaling and how to make adoption happen. So my next question will be to Laetitia. Agri-food tech investment peaked in 2021 at $51 billion and has since leveled up to $16 billion in 2024. Is this stabilization a healthy correction or a warning sign?
So indeed, there has been a huge decrease in the investments in the food and ag sector over the past 3 years. I do think that it is a healthy sign of the general ecosystem as long as it does not last too long. So why is it a healthy sign? First of all, the 2021 figure that you mentioned, you have to take into account all of the mega rounds, specifically of the quick commerce startups back then, which is a bit of a different type of business models, which is less and less current today. But also it's a healthy sign because I think the startups today are also trying to be more resilient and less dependent on new capital, new money coming in. Here in France, there is a huge surge of bankruptcy, which is, of course, a shame. But we see that the startups that are the most hit are the ones that are 8 or 9 years old, because those are the startups that were created during another time, another world, where the cash culture was probably a bit less king than it is today, or that it is becoming with today's startup creation. So I do think it's a healthy sign. Now, it's hopefully not going to last too long, this decrease in investments, because we need the money, obviously, to support the innovation. And the good sign is that the agri-food tech in the US, the investments is, I hope, starting to pick up again, with a 14% increase from 23. So still a big way to go to increase that number again, but it's starting to go the right direction, I hope.
Great. Well, let me still with you. What type of investment actually gets solutions into farmers' hands?
Yeah, this is a very good question. What type of solution does farmers actually want? I think this is a question that is often forgotten, and maybe a bit of a personal anecdote here. So my uncle is a farmer, and last week I asked him what solution he actually wanted to be financed for him to ease his day-to-day life. So I was expecting something complicated, AI-related, robotics, or whatever. What he answered is something that would scare birds away and prevent them from actually eating my seeds. So very basic. Actually not that simple, because birds, and especially ravens, are extremely smart birds. But that being said, get pragmatic solutions, get solutions that a farmer would get immediate return on investment on, and that would not dramatically change his day-to-day habits.
Okay.
I think these are the three main points that I would say.
That's a good one. Then over to Guy. You work on open source and robots, a radical different approach to farm technology. All right. Now, what's the vision here, and why are you doing this?
Yeah, I think it's probably a nice segue from what Laetitia was talking about, because if you sort of go back to what farmers really need, or what they're constrained by, you have they're just trying to produce as much as possible, generally constrained by things like the environment, regulation, sort of finances, and then I guess sort of weather and the timing of all that. So if they're the constraints, then and they have to produce as much as possible within that sort of framework, then you really force farmers to be quite innovative with what they have. And the next part of that story, I guess, is that every farm is very niche. So your uncle, I guess, has very different requirements to, say, my dad in the southwest of Western Australia, or sort of farmers in the US or in Denmark in Northern Europe. And so going back to the open source technology side, that's where we start to share these base recipes. So maybe a basic way of scaring birds, or a basic way of detecting weeds in my case. And you let people sort of build on top of that, and that might be in a private way, but it just saves people doing the basic sort of boilerplate, or the fundamentals over and over again. And for example, in Paris, there's a lot of croissants around, but there's also a croissant recipe you can go on Google or ask ChatGPT for. Yet somehow all the boulangeries are very successful. So there's almost this sort of paradox of how do recipe books exist and how do restaurants exist. And so how then we create these recipe books for agriculture that allow us to advance much faster and end up with solutions that are much more adapted to each niche use case. So that's the sort of idea behind open source, and I guess my vision for it.
Okay, great. So what are the biggest barriers to scaling open source solutions?
At the moment, it's probably maybe a recognition or a move away from the status quo. So in agriculture, it's very much proprietary driven. Everyone keeps a hold of their secrets and doesn't want to share them. And that secret might be a data set, or it might be some sort of algorithm. Maybe it's a development in sort of machinery. But if you look over, say, technology industry, so the machine learning field, that's very much built on open source development. I mean, all these servers that are probably running half this conference today are running Linux, which was developed in the 2000s or 1990s as an open source operating system. And I think some of the barriers, if we try and overcome that acceptance of being open about some of these base recipes, or opening up or developing some sort of open source strategy within your organization that shares maybe some non-critical component, but it may help others sort of build off your technology, that would really go further. But there is some issue with scaling as well. I think at the moment, most attempts are quite fractured. Even my own, with the open weed locator, it's a little bit challenging to try and to scale it. But the organic growth does certainly help.
Okay, but do you think open source solution is a viable alternative?
Yeah, I would certainly agree with that. Okay. I mean, you look at Mozilla Firefox, that was pretty popular, Android, open source. Meta, they publish lots of open source stuff, and I don't really think they're an altruistic, necessarily, organization. So there is certainly viability in open source development. It's not giving away things for free. It's more about ensuring we can stand on the shoulders of others, to sort of use that well-run quote.
Okay. Please, let me just, to remind every one of us, you can go on the app and send us your questions, or you can scan the QR code to send us your question. All right, thank you. Back to Evan. Can biological replace synthetic pesticide, or is it a hybrid future? What do you think?
Well, that's a good question, and there is a lot of debate about it. I think we should not forget that plant diseases are really something that is developing very quickly. It's actually a very complex problem, and most of us are very far from farming, and we don't realize anymore how difficult it is to grow healthy crops. Maybe if you grow some crops at home, you realize how difficult it can be to grow tomatoes, but pests are everywhere. And so the problem is very complex, and the answer on complex problems is never a one solution. So I'm a fan of a diverse offer after it. It starts with the seed that we select, the right crop to grow, but it's also a diversity of all types of biocontrol products that it will be in the future. Not only one, and maybe at the last resort also chemical products. We should not forget them as well. But biocontrol products can be much bigger, and they will be much bigger. They are growing massively, much more than chemicals. So the growth rate of chemicals is now 5 to 6% yearly. For biologicals, it's more 16%. So we will see that, the part of the biologicals will be much more in the future, but it will not be only biologicals, I believe.
Okay, that's a good one. Thank you. Okay, back to Laetitia. What are the biggest mistakes agri-food tech makes? Some of the mistakes you think agri-food tech makes.
Agri-food tech investors.
Yes, agri-food tech investors. Sorry, yeah.
So I think one of the biggest mistake we made, and this is also referring to what you were saying, Eva, is to not consider the time that agri-food tech space requires. As you were saying, biologicals, they have a 10-year regulation to the market. It's the case for most of the solutions today. The reason being that you basically, for agri-solution, have 1 or 2 shots per year that are corresponding to your harvests, to your crops cycle, whereas in software you have basically as many potential testings as you'd like. So we tried to plug in a very Silicon Valley VC type of financing model to a sector which is requiring a lot more time to go to market. And to that extent, it's a lot more comparable to a pharma type of industry, for example. I think this is the biggest mistake, if I had to name one, that we made as investors. And I do think that to have real impact on agri-food sector, you need to be patient investors.
Okay, great. Thank you. I have some questions from the audience already, so I think we should take them before we continue. All right, this one is to Ivan. He said, what regulation exists now and is incoming for replacing chemical pesticide? When will this regulation be in place?
Yeah, the question is then in which region we are talking. If we're talking in Europe, actually the regulation on pesticides is in place and is also valid for biologicals. So there is no special regulation for biological products. Even there is no definition in Europe what it is. So if you want to sell something with the claim that you treat a certain pest, it falls under the chemical regulation. And on this moment, I believe that will stay for some time. Luckily, there is now the Biotech Act coming, and the Biotech Act is not only serving crop protection biotechnologies, but also other biotechnologies. But also there we want to push, regulators want to push that regulation can go faster for new products like biotech crop protection products. So there are now, the Commission is now thinking about amending the original chemical regulation, but these things will take time. So me now forecasting when that will be is very difficult, although they have the plans to install first proposals by autumn this year.
Okay, great. Thank you. We have another question here, but I think anybody on the panel can answer this question. Modern farming methods are associated with many problems, like decline in soil quality and the exhaustion of soil. How can sustainable farming improve this?
I can speak to that from a precision point of view, I guess.
Yes, you can go ahead.
I think in some areas that there are challenges in degrading soil quality and soil health and sort of other environmental factors. And I think the way maybe that has come about is because we treat every part of the field in the same way. And so technology, I think, is a major part of the future of sustainable farming, because we can get back to more individual ways of managing each kind of unit area. And maybe the way we sense that is through cameras for weed detection, where we only apply herbicides or biologicals or lasers to a weed instead of the rest of the crop. Or perhaps in the case of some sort of pre-emergent herbicides or where the crop hasn't come up yet, and you might try and stop the weeds before they get through the crop. If you look at, say, temporal or satellite data over 5 years, then you can start to predict where the weeds might emerge and then only apply herbicides to the particular areas where those weeds are. Or even use things like higher crop density so the crop outcompetes the weeds, or change fertilizer regimes to outcompete the weeds there. And all those approaches, I think, are a very key part of sustainable farming. So that combination of technology, I think, refining the way we approach these problems is hopefully part of it.
Okay, great. But still on, does anyone want to add more to what Guy just said?
Yeah, without repeating what you just said, and back to my uncle, whom I love. So when I ask him and have a debate with him on weeding, on computer vision, he's saying always, like an old chap, yes, but we were already doing this in the 90s together with Kodak. Well, we know where Kodak is right now, but that to say that we always think that we have tested it all in a way. I think where we are lucky right now is that we have sufficient technological power to be able to have those solutions at scale and to apply them in agri-food where the margins are very low and where you need to have solutions that are scalable extremely easily. So how do we make the future of sustainable farming? Definitely with technology.
I think one thing I found just quickly is like some of the first patents on precision plant detection, I think was from 1972 or 1970s, and so it has been around for a long time. It's just, yeah, as you say, there's that scale potential now that hasn't really been there.
Okay, thank you very much. You want to add anything more? Oh, okay, but still on Guy. Who funds open source solutions, and can this model ever compete with proprietary technologies?
I thought sort of like the provocative answer to this question is I think, can proprietary technologies ever compete with open source stuff? Because at least on the development front, I'm not sure about the funding. That's very different. Maybe get your comment on that. But if you go back to what Linus Torvalds, the creator of Linux, says back in the early 2000s, and a few of the other open source advocates from back then, they talk about how open source enables you to really capture the almost like natural evolution of software. It's less design and more evolution. And it's very difficult to iterate faster from a closed production team that's maybe sitting within John Deere or sitting within Case New Holland than it is to sort of iterate much faster when you build in the open and you have everyone contributing to your project and you have much sort of greater pool of minds thinking about it. And that's one of the strengths of the machine learning community. Google published in 2017 the Attention is All You Need paper, and then 4 or 5 years later we have ChatGPT, which is based entirely on that research. So without that publication, would we have got ChatGPT as fast? And if you ask ChatGPT, it says no. So there's that. So I think in terms of development, I think proprietary is actually probably much slower than building in the open. But it's just we haven't practiced it as much in agriculture. And if you look at OpenAI, just as a more of a broader tech industry comparison, they're a closed company. And you look at all the open source developers out there, and they're catching up or overtaking what OpenAI are doing, or such as DeepSeek, which is an open source model, Mistral AI from here in France, they're also open. So I think that development side, the funding side is certainly a challenge, because if you go to a VC and say, well, the first thing I'm going to do is share everything publicly, then I'm not sure that really works for.
We don't like it.
Exactly. So funding is a tricky one, and then perhaps that's where you might get farmers involved, or maybe more bottom-up driven funding, and that's probably my experience with it, where lots of farmers get interested, they might bring other farmers involved, or get them involved, and then sort of go from there for driving a particular project. But whether that scales rapidly, but it is challenging, but maybe it scales into that particular niche, a group of farmers, say in the southwest of Western Australia, for example. But yeah, I'm not sure how that scales more broadly.
Okay, thank you very much. So we have some more questions from the audience. One said, do you think polyculture will take a significant role in the future of agri? And how do we build systemic knowledge? Do you want to go? Do you think polyculture will take a significant role in the future of agriculture? And how do we build systemic knowledge on this? Yeah. So, I think, I don't know what he means by polyculture, but maybe...
You mean polycultural?
Yeah.
So I guess the agri-food system has been built on making, as much as I was saying before, as much economies of scale as possible since World War II. Hence the fact that we've moved from a polyculture to a huge, intensive monoculture system, which is indeed more efficient in terms of economies of scale. But doing this, we have made soils that are extremely poor, and poorer year after year. And we've probably shifted towards something that resembles cheap calories for the food system, because we needed to be able to feed a growing population. The result of this is that we have lost a lot of biodiversity, a lot of richness of soils. So going back to polyculture would definitely help on this regard. The thing is, it needs to be as efficient in terms of economies of scale as what we have built in terms of monoculture. So I don't really know if that answers the question, but that would be my guess.
Okay.
And maybe to add on that, I think if we want to make the most impact with agriculture, the solution is also that we make wise choices in what we eat and what we grow. I think the biggest impact that we can make is there to grow more plant-based proteins, for instance, and together with polyculture and then together with technologies. But the first thing is this, to take wise choices on what we take on our plates.
Okay, thank you very much. All right. How consistent and regular is the usage of precision farming currently? So, how consistent and regular is the usage of precision farming currently?
The usage of precision farming?
Yes.
I'd say it depends on which area you're in and which type of precision agriculture it's about as well. So, speaking mostly from Australian experience, in Australia there's widespread adoption of things like GPS for like self-driving tractors, and that's been around for 15 odd years.
Yeah.
And that has helped with things like inter-row planting and managing wastage between sort of overlaps. I think what we're seeing now, and so you get a lot of advancements from using GPS-guided tractors and knowing what's planted where. And that's also adopted in the US, I think Canada, probably South America, I think in Europe in some cases. So it's more suited to large fields where you just drive straight lines for an hour on end. I think what we're moving to now is more that on-implement sort of vision technology and more sort of real-time sensing based precision agriculture, and that's probably far less adopted. For sort of precision weed control, I think in Australia you've got probably a few thousand implements using, I guess, some form of sensing, not necessarily imaging, for spot spraying. I think John Deere claimed they'd gone over 1 million acres in the previous year with about 59% herbicide savings. Then I think in South America they've deployed sort of a few dozen machines as well, from what I've read, and it's certainly growing, at least for spot spraying, and lots of those precision sort of vision-guided implements, but I think we're still at that very much early adopter phase. But things like laser weeding are also quite exciting. Laser weeding robotics from, I think, carbon robotics, they've expanded quite rapidly, but their machines are well over sort of north of $1 million US. So again, you're only getting that into the much larger farms where the scale can make it work. But it's growing, I think, and as we get more implements into the field, then I think we'll see that hopefully some of those problems come down, and maybe the pricing as well, so more smaller farms can adopt too.
Thank you. Okay. So this question is to Laetitia. Do you see more promising solutions in the agri-food tech space coming from hardware or software solutions?
Yeah, thankfully we see a lot of solutions today. I think we've tackled quite a lot the precision agriculture space, so I won't go back into this, neither in the biological space, again, which I think is definitely something to be looked at. I think there is one thing which is pretty much of an enabler of all of this, which is, of course, AI. So when you look at the big mega rounds of US agri-tech startups last year, out of 20, 13 were using AI. So depends on what you call AI, that's for sure. But now I think this will enable a lot of different technologies to be more fundable by VCs probably in the next very short term. And these are very interesting innovations in the future.
Okay, go ahead.
Absolutely. Also at Biotalys, we see that AI plays a crucial role. So what we actually do is selecting the antibodies from llamas, so it's a whole technology. I would need some time to explain it. But the llama is producing actually millions or trillions of antibodies, and what we have to do is to select the stable one, the most active ones to be used in our products. And also there AI plays a crucial role where our innovation cycle can now go much faster. And we're probably not the only company that can benefit from it, and make sure that the products can be developed faster. So now we're just waiting on the regulators to have a look at them and give us predictable timelines. And maybe what I also still want to add, that the adoption of biological products is happening when you make them available to farmers. So the market share is still quite small, but it's just because they're not available. You see that there is only one country in the world that was able to deregulate effectively on biocontrol products. So the chemical process in Brazil was also taking 8 years. But they found another regulation, or they established a regulation specifically for biocontrol products. And there they managed to evaluate dossiers within 1 to 2 years. So the products available to the farmers are much more available. And then you see that the adoption is also increasing. So there the growth rate for biologicals is 45% in the last years, compared to where it is, like I said, only 16% on average in the other regions. So when you deblock the regulation, when you go faster there, then the adoption is faster. So that would be fantastic if we could install that also in other regions and follow the example of Brazil on that part.
Okay, thank you very much. While we bring this panel to close, this will be my final questions to each of our panelists. If you were to bet on one technology or trend that will define sustainable farming in 2035, what would that be? In 1 minute less. Go.
For me, it will be proteins. I think proteins treating diseases can really be big, proteins and peptides. So I'm very curious how big it can be.
Great, thank you very much.
I won't surprise you and be consistent with my last answer, and definitely yes. AI. And maybe one example to AI applied to R&D in the case of biologicals. As you might know, the scientists today, or might not know, the scientists today are using Petri dishes to be able to scan the different microorganisms that are the most efficient. So first time I went into a lab, I saw a bunch of scientists that were actually measuring the spread of the microorganism in a Petri dish, which is not the best use of their time. So what we have done at Astanor is to invest in a company called Reshape, which is actually screening those Petri dishes with computer vision, with AI, to be able to save time to the scientists to have more value add on other types of actions. So just one example and one marketing example for Astanor.
Thank you. Guy?
I think I love the idea of sort of like problem-driven solutions through sort of natural language, where you have farmers that are sitting on these massive data sets they've probably collected over the last 15 or next 15 years, 10 years. And with that data, then they just ask a question and say, okay, let's just manage this particular problem in this field, and then instead of having these specific apps or things developed for specific problems, it's more of just a framework that exists that's in the tractor that then just activates the nozzles over particular plants, if that's for fertilizer or for herbicide or whatever it is. So I think it's more about having technology that allows, I think, farmers or the people with the expert ideas on the problems to then just create solutions themselves. And I think that would be an interesting future.
Thank you very much. I guess this is the point where we now put our hands together for all our panelists. Thank you guys for the questions so far, for answering the questions and providing answers to the questions so far. It's on this note to bring this session to an end. I think we're supposed to take a good picture. It's on this point we're bringing it to an end. Thank you very much.
Thank you very much.
Thank you, guys. Thank you. Thank you very much.